Hello, you discrete math luminaries. This is the first official lecture in the coronavirus era. I decided that I'm not going to do things via Zoom, which is a platform that Cedarville has purchased access to enable meeting formats. I'm going to do the lectures in a video style and just post them on Canvas. And then I will use our class time to field questions in a live Zoom format. Okay, so I'll use Zoom during our regular class time hours, but I will only be taking questions on the lecture, questions you might have about course material, what have you. But the lecture itself will take place in these recordings. Okay, does that make sense? So I'll send out invitations to those Zoom sessions. There will be some that are more generic, just office hour type settings, and then there will also be Zoom sessions specific to this class. So you can always come to either one of those, and you'll get invitations to those later in the day on Sunday here. Today is the 15th, and I'll send out all those Zoom invites this evening or tonight, just so that it's kind of fresh in your mind. And that's how we'll proceed from here. Okay, so hopefully that kind of makes sense. All right, well, let's get to it. I'm not going to lecture for huge amounts of time in these mini lectures because I've just learned my lesson that if I lecture for too long, something inevitably goes wrong and the videos take more time to upload. So I'm just going to talk through several of these slides. I'll probably just talk about conditional probability, and then I'll stop, and then I'll move on to the next topic. And that's how we'll proceed. So usually, 15 to 20 minutes or so, stop, and then I'll do another video. And a few of those will constitute like one lecture, basically. Okay? All right, so let's talk about conditional probability. Okay? Again, I've kind of articulated what the general idea is in class. Namely, we're now computing probabilities of certain events given information about the events in question. Okay? So the example I gave in class was, hey, if suppose I draw a random card and I tell you the card I drew is a heart. And then I asked you, what is the probability that the card in my hand is the Queen of Spades? You would immediately say 0 because the calculation has changed. Now that you have this given information, you know that the probability of it being the Queen of Spades is 0 because the Queen of Spades is not a heart. And I told you that the card I had in my hand was a heart. On the other hand, if I didn't give you any information at all, then you would have to say that the probability that it's a Queen of Spades is 1 out of 52, since there's only one Queen of Spades out of a total of 52 cards. Okay, so conditioning on information, that is the nature of conditional probability. Okay, so conditioned on information, given information, we'll use those terms interchangeably. All right, so for any two events, A and B, you want the probability of B to be greater than 0, then the conditional probability of A given that B has occurred is defined by that formula. By the way, we call B the conditioning event. Okay, and we're computing the probability of A conditioned on B, or the probability of A given that B has occurred. Okay, and that's that little bar that you see right here, that little bar. You kind of want to insert the word conditioned on or given when you read that from left to right. And the formula is, it's going to be the probability of A and B happening divided by the probability of B. And there's a good rationale for this. Here, let me expand this out a little bit. Okay, there's a good rationale for this. So let me see. I want you to see the formula right there. Okay. Let me draw a picture of what's happening. Okay, so here's the whole sample space. Okay. Here is the event A, and here is the event B. Okay. If I tell you that B has happened, if I tell you that B has happened, the sample space is no longer everything. The sample space is now this. Okay? Okay, so given B, B becomes the new sample space. Okay? So B is like the new S. So now if I ask for the probability that A has occurred, given B, then all this junk over here outside of B is no longer relevant to us, because that's not even in the sample space anymore. The only stuff that would matter to us is this stuff right here. Okay? So this thing right here is the only thing that would matter to us. Okay, and so we would just take that stuff, the proportion that this stuff takes up of the new sample space, B. You would take the proportion that this stuff takes up of the new sample space, B. So it makes sense that the probability of A given B would be equal to, well, what is that? That's the intersection of A and B. So it would be the probability of A intersected with B divided by the probability of B. Okay, because the probability of B is this within the whole sample space. You want to take the proportion of this over this football shape takes up of B itself. So that's why the formula for conditional probability makes sense. Okay? All right. All right. Let's keep going here. Okay? So, all right. So what about the intersection of two events? Well, we can actually use conditional probability to compute the probability of the intersection of two events. Okay, because here's how this works. If I want the probability that A and B occurs, so think about this. The probability that A and B occurs, this is going to be, okay, what you can do is you can say, well, look, suppose that B happens. So how often does that occur? Well, this often. The probability that B occurs. And then you say, okay, but I don't just want B to happen, I also want A to happen. But now I know that B has already happened. And as such, we no longer think of the entire sample space as being possible. B has already happened. Therefore, we are now zoomed in to the sample space right here on B. We've zoomed in, and we want to know, okay, what's the probability that A happens? And now we have to condition on B having already happened. So B happens, and then we need A to happen given that B has happened. Okay? This formula right here, by the way, is just a rearrangement of the formula for conditional probability that you see up there on the top of the board. Yeah. So this formula right here, all I've done is multiplied through by the probability of B. On the slides, I mean, it's not really written sequentially the way I just talked about it. I like to think about it as B happened. So if I want A and B to happen, B happens, and then A happens given that B happens. that B has happened. Okay? And in that way, you can kind of see why this formula down here makes sense. Okay, what the probability of A and B and C, the probability of those three events occurring. Well, I can think about them sequentially. Read it right to left, actually, the way this is written. Okay, C happens. And how often does that happen? Well, probability of C. And, so times, the probability that B happens, given that C has already happened, because it did, right here. And at this juncture, like C has happened, B happens given C. So B and C have both happened at this point. And now I want A to happen. Given what? Given that both B and C have happened. And incidentally, you can kind of mess with this. Watch this. Watch this. So look at this. So the probability of A given B and C times the probability of B given C times the probability of C. Well, you can kind of unravel this formula just by plugging in the formula for conditional probability. The formula for conditional probability says that this first factor is just the probability of this event intersected with this event. So it's the probability of A and B and C divided by the probability of B and C, right? That's what the formula for conditional probability says up top, yes? Okay, the probability of this event given that event is the probability of the intersection of those events divided by the probability of the conditioning event. Okay, that's exactly what we've written down here. Okay, what about the probability of B given C? Well, that's the probability of B and C over the probability of C by the formula for conditional probability. And then finally we have the probability of C. And oh happy day, all of these things cancel and you are simply left with the probability of A and B and C. So that's kind of another way to see why this formula is true. Okay, this stuff makes good sense. All right, so moving on. Okay, here's a little problem for our, to kind of make sure this is sinking in. So a box contains 6 red balls, 4 green balls. Another box contains 7 red and 3 green. Okay, so we have 2 boxes, each with 10 balls, 6 red, 4 green in one, 7 red, 7 green in the other. A ball is chosen randomly from the first box and placed in the second. Then a ball is randomly selected from the second and placed in the first. What is the probability that a red ball is selected from both the first and the second box? Okay. So let's introduce some events so that we can kind of talk carefully about what we mean here. So let's let R1 be red from the first box. Okay, so that's what R1 is going to be, red from the first box. And let's let R2 be the event, because remember we're doing this in sequence. So we have a first box and a second box, right? So we can tell the difference. Like the one on the left is the first, the one on the right is the second or something. Okay, R2 is the event red from the second box. Okay. Well, what we want here, so it says, what is the probability that a red is selected from both the first and the second? So this is the probability of R1 and R2. But we know how to do this using conditional probability. Okay? So it's going to be, well, what's the probability of R1? Okay, so what's the probability that we select red from the first box times the probability that we select red from the second box given, right? Because R1 has already happened at this point. R2 given that we selected red from the first box. Okay, so what are those things? Well, the probability that we select red from the first box, that's kind of easy. That's just, so the first box has 6 red and 4 green, so it's 6/10. Okay, times. All right, so now the thing is, we from the first box, we take a ball and we transfer it to the second box. Okay, so that we picked a red ball and we transferred it to the second box before choosing a second ball. Okay, and then we transfer that thing back to the first box. It says, what is the probability that a red ball is selected from both the first and the second boxes? So we transferred a red ball from the first box to the second. Now there's 11 balls, and incidentally, there's also 8 reds because we transferred a red ball over. So that's 8 reds and 3 greens at this moment. Okay, that's the information that we're given here. Okay, we know there's 11 balls total. We know that the one that was transferred was red, and hence the probability that we select a red second, given that we transferred a red on the first, is 8/11. Okay? And you might say to yourself, wait a minute, I thought that we had to use that formula for conditional probability to compute the second thing. Yeah, I mean, we could have done that too, but this conditional probability, it was we could just kind of think our way through it. But watch.